Question 20. You have this set of numbers. Complete the table by placing each of them in the right column. You have pi, 1 over 3, 1 over 4, 1 over 7, square root of 2, square root of 5, and square root of 9. One has been done for you. You have the rational column and the irrational column. Now under the irrational column, the one that has been done is pi, which is the very first one. You know, pi is an irrational number. You should know what irrational numbers are. Irrational numbers are numbers that can't actually be expressed as decimals. Now, in the case of pi, you know that pi can actually be expressed as a decimal, but it's approximately 3.14 in some cases, and in others it can be given to you as 3.142. But this is not the actual value of pi in decimal, it's just an approximate. Pi as an irrational number can actually be described as a non-terminating, that's non-ending, and also non-reoccurring. That is, if you are to express pi, you have it as 3.14159265359 and so on. It doesn't stop. It doesn't terminate. That means it doesn't have an end, and it doesn't reoccur. If it were to reoccur while non-terminating, it will be termed a rational number. That is, reoccurring in sense of you have 3.141414. You can see the pattern. It's reoccurring. You have 141414 reoccurring. Say it's continuous. That makes it non-terminating. It doesn't end, but it has a reoccurring pattern. That's 3.141414. It might even be 142, 142, 142, like that. That's a reoccurring pattern. Or it can be 3.11111. That's also reoccurring. If you have a sort of decimal that doesn't end, but it's reoccurring, that is, it's in repeat, then it can be termed a rational number. So pi is irrational. It's only given to you in approximate. The next is 1 over 3. For you to know if 1 over 3 is rational or irrational, we have to convert it from fraction to decimal. So you have 1 over 3. This question is not just testing you on your knowledge of rational and irrational numbers, but also testing you on converting fractions to decimal. So 1 over 3 to decimal, you have your dividing sign, you have 1 on the inside, 3 on the outside. 3 is the denominator, that it's dividing 1, and 1, which is in the numerator, is inside. So we have 3 in 1. That's impossible because 3 is greater than 1. So we have to increase this 1 by adding a 0 to it and making it 10. And once you do that, you have to add 0 points as part of your result. So 3 in 10 is 3. That's 3 times 3, that's 9. 3 times 4 is 12, that's bigger than 10. So you have 3. You have 9 here. Then you rule your line and subtract. 10 minus 9 will give you 1. 3 in 1 is impossible. Once you have a decimal, you can just include a 0 to the 1, making it 10. 3 in 10 is still 3. You have 3 times 3, that's 9. You subtract, that will give you 1. That's 10 minus 9 will give you 1. 3 in 1 is impossible, so you add a 0 to the 1, making it 10. 3 in 10 is still 3. That means 1 over 3 is actually 0.3333 non-terminating, that's not ending, but it has a pattern. You can see the 3333 repeated. That means if you have it in this form where it is repeating, it's termed a rational number. So 1 over 3 is a rational number, so you have it here, 1 over 3. The next you have is 1 over 4. That's also a fraction. You have to convert it to a decimal to know if it's rational or irrational. So you have 1 over 4. You have your dividing sign. You have 1 on the inside, 4 on the outside. The 1 is the numerator, the 4 is the denominator. So you divide. 4 in 1, 4 is greater than 1. So you cannot have 4 in 1. So you have to add 0 points. Then increase this 1 to 10. 4 in 10 is 2. Because 4 times 1 is 4. 4 times 2 is 8. That's less than 10 and close to 10. 4 times 3 is 12. 12 is higher than 10, so you can't use 4 times 3. Best fit is 4 times 2, which is 8. So you have 4 in 10, that's 2. Then you have 2 times 4, that's 8. You write the 8 under the 10, then you subtract. 10 minus 8 will give you 2. 4 in 2, 2 is less than 4. So you have to increase the 2 by adding a 0 to it and turning it into 20. So you add 0 to it. And 4 in 20 is 5, because 4 times 5 is 20. So you have 5 here. Then you have 5 times 4 or 4 times 5, that's 20. You subtract. 20 minus 20 is 0, so you can have 2 dots here. 1 over 4 as a decimal is 0.25, which is a terminating decimal, that it ends. And if it ends, it's termed rational, because rational numbers are numbers that their decimals are terminating, or if not terminating, they are repeating or reoccurring. Just like we have 0.3333, this is repeating or reoccurring. The 1 over 4, which is 0.25 as a decimal, is a rational number. So we have it here under rational, 1 over 4. The next is 1 over 7. You have 1 over 7. We're converting it from a fraction to a decimal. And like previously done, you have your dividing line, you have your 1 inside, 7 outside. 7 is the denominator, so you have it outside. 1 is the numerator, you have it inside. 7 in 1, 1 is less than 7, so you increase the 1 to 10 by adding 0 point. 7 in 10 is 1, because 7 times 1 is 7. 7 times 2 is 14. 14 is higher than 10, so 7 times 2 will not work. So you have 7 times 1, which is 1. The result, which is 1 times 7, will give you 7. You subtract 10 by 7. 10 minus 7 will give you 3. 7 is greater than 3. So you have to increase this 3 by adding a 0 to it to make it 30. So you have 30. 7 in 30, 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 28 is very close to 30 and is the best fit, because 7 times 5 is 35, which is higher than 30. So it's 7 times 4. So you have 4 here. 7 times 4 is 28, so you have 28 here. That's 30 minus 28 will give you 2. Because 0 minus 8, 0 is less than 8. That won't work. So we borrow 1 from these 3. You'll be left with 2. This is now 10. 10 minus 8 will give you 2. So we have 2. Then 7 divided by 2 is impossible. 2 is less than 7. So we increase the 2 to 20 by adding a 0 to it. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 21 is higher than 20, so we can't use 7 times 3. We use 7 times 2. So you have 2 here. 7 times 2 is 14, so you have 14 here. So you have 20 minus 14. You borrow 1 from here, and this is 1. This will be 10. 10 minus 4, that's 6. 1 minus 1, that's 0. You have a dot here. This is 6. 6 is less than 7, so 7 can't go in 6. You increase the 6 to 60 by adding a 0 to it. 7 in 60 is 8. 8 times 7 is 56. So you have that's 56. You subtract. 60 minus 56, you borrow 1 from here. This becomes 10. This is 5. 10 minus 6, that's 4. 7 in 4, 4 is less than 7. So increase it to 40. 7 in 40, the closest is 5. That you have 5 here. 7 times 5 is 35. 40 minus 35 will give you 5. 7 in 5 is impossible. So increase the 5 to 50 by adding a 0 to it. 7 in 50 is 7. Because 7 times 7 is 49. 50 minus 49 is 1. The 1 won't work, so increase it to 10. See, we're back to this 10. And if we continue again, you do 7 in 10, it will be 1, you have this 7. Then you go back to 3, then you increase it to 30, you have 2. You'd actually see that 1, 4, 2, 8, 5, 7 will repeat. You still have 1, 4, 2, 8, 5, 7. It's going to be continuous. That after this set, you have another set of 1, 4, 2, 8, 5, 7. This is a non-terminating decimal. That is, it doesn't end, but it's repeating, or it is in a recurring pattern. Therefore, 1 over 7 is a rational number. So we have 1 over 7 as a rational number. If you can go back to your school notes where you are taught rational and irrational numbers, you would know that the square root of 2 is an irrational number because it can only be approximated into a decimal. It's non-terminating and non-repeating. Square root of 2 is actually 1.41421356 continuous. It's non-ending, that it doesn't terminate and you don't have a recurring pattern. Therefore, square root of 2 is actually irrational. Square root of 5 is also irrational. Anytime you find the square root of a number and it's ending in decimal, it's most likely going to be irrational. But if you find the square root of a square number, for example, square root of 9, where you get a whole number for your answer, is definitely a rational number. So square root of 9 is a rational number. So we have it under rational number, square root of 9. Hope you understand. This is just to test your knowledge of not just rational and irrational numbers, but also having to convert fractions to decimal, particularly when it comes to using long division. You know, some students struggle with long division, but this is an opportunity to learn long division. Hope you understand. You can do more research on types of numbers